The rest of these questions go along with this table given to us, and it says that Harvard University consists of 12 schools, 3 of which are law, medical, and education. So we're only going to look at law school, medical school, and education, and then we have a breakdown of women versus men. So here is the um, table that gives us the breakdown of what they teach and if they are a male or if they are a woman and their totals as well. So this first question says, what is the probability that a faculty member selected at random is a man if it is known that the faculty member teaches law? So conditional probability here because we know that it's known that the faculty member teaches law. So what we're going to do here is we are going to restrict our denominator. We know that the faculty member teaches law, so that means that we are working just right in here. All right, so this is what we are working with right here, that they teach law, which means that the denominator is going to be 238. That numerator is going to then be what's the probability that the faculty member selected is a man? So if we're in this first line only, how many men are there that teach law? That's going to be 136. So then you would use a calculator and take 136 divided by 238, which would get you to the 4/7. Similar next question, only this time it says if it is known. So this is the condition that we have. This is how we're going to restrict our denominator. It is known that the faculty member is a woman. So that means that we're only looking in the woman column. So woman column, the total is 180. So that's our denominator. What is the probability that a faculty member teaches education? So looking in here only, teaches education, that would be 10. And then you would just simplify that down. The next two questions are a little bit more challenging, but not too bad, especially if you know your formula for independence. So are the events men and education independent? So formula for independence is that their intersection is equal to individually those multiplied together. So in our case, men and education would have to be equal to the probability of whatever it is for just being a man, and then times the probability of being a faculty member in education. And what we're trying to figure out, is this true? This is our question. This is what we're trying to figure out. And if it is true, then it means that they are independent. And if it's not, then they aren't. So let's go ahead and start off with these first ones. So the probability of being a man. So we have 240 men out of 420. So this would be 240 divided by 420 times the probability of being teaching an education. There are 34 total there out of 420. Okay. Probability of a man and an education school, teaching in that school. So we still have that denominator of 420, but now we're looking specifically about being a man in education. That's right here. So that's going to be 24. So that's going to be 24 out of 420. And so multiply over here, see what that gets you. Does it equal the same thing as 24 over 420? And in this case, that answer is no. So this next question, very similar, but now we're doing probability of man and law, and that would have to be equal to the probability of being a male professor times the probability of being a law professor. And so these probability of being a male professor, that's still the same as up above. That would be 240 out of the 420. The probability of teaching law, there are 238 law professors out of 420. So this would be 238 out of 420. Probability of being a male that teaches law, remember our total is 420. But male and law, that's this one, 136. So multiply those together, see if that gives you the same thing as 136 divided by 420. And it does, which means that this was satisfied, which means that yes, the two events are independent because this formula for independence has been met.